Algebra Word Problems number 4B, Combining Like Terms in Word Problems Part 2. We had a 4A, so this is going to be 4B, and some of the things may seem repetitive, but that's okay. Maybe you'll remember it even more. And if you haven't seen it before, you'll be glad I said it this time, okay? So word problem strategy is we read the problem carefully, we underline or circle the important parts, we make a plan, like figuring out which operation to use. Do we add, subtract, multiply, or divide? We figure out how we're going to use the information, and we need to turn the unknown amounts into variables that make sense. If it's really confusing, we can make a table or a diagram to help us figure it out. We write our equation, find the solution, and then we check to make sure we did it correctly by plugging in our answer. That's if there's like an actual answer. So remember that this guy next to the alphabet letter, this is a variable, this guy is called a numerical coefficient. Okay, he's a coefficient, and the variable takes the place of an unknown number, all right? So, as I said in the last video, a term is a number, it's letter or letters, number and letters combined by multiplication or division, or both. It's not combined by addition or subtraction, it's multiplication, division, or both, okay? This is a standalone 9, that's considered a term. X by itself is a variable, that's considered a term, and so is xy, which means x times y. 8xy means 8 times x times y, that's a term. 3x means 3 times x, and it's over y, that means 3x divided by y. And then we've got 6x cubed y squared, see? That's a term also. This whole thing is one term. Terms that have all the same variables with the same exponents are called like or similar terms. So 3a is a like term with 2a. 4xy is a like term with 15xy. See how they have the same variables and then the numerical coefficient might be different, but it's got a number and then an x and then a y, so it makes them like terms. If we added these two together, we'd have 5a. If we added these two together, we'd have 19xy. A and a is like a 1a and a 1a, so we have 2a, see? When we do terms like this, we just copy the exponents and the variables off on the side, and they don't get added together. We just add together the numerical coefficient, the coefficients in the front. 5 and 8 is 13, so it's 13x cubed y squared, see? And this one has an invisible 1 in front of it, so 4ab, and ab is 5ab. So we combine these like terms by combining the numerical coefficients, these numbers in front of the variables, by the operation that's given to us. And we have to remember our rules of positive and negative numbers in the order of operations. So take a look at this messy word problem. It's because I circled and underlined some important words. A package of 3 golf balls costs $2. A box of golf tees costs $. Write an expression for the total cost of 4 packages of golf balls and 2 boxes of golf tees and simplify the expression. All right, so what's important? A package is 2z, right? And a box is z, all right? So we need the cost, the total cost of 4 packages and 2 boxes. See that? And we need to simplify it, all right? So we think 1 package of golf balls costs 2z, so 4 packages would be 4 times the 2z, right? 1 box of tees costs z, so 2 boxes would be 2z, 2 times z. And then we need an expression for total cost. So we've got 4 times the 2z and 2z, and it has to be totaled. So that means it has to be added. 4 times 2z and the 2z. 4 times 2 is 8, so that gives us 8z. The 2 and the z gives us 2z. 8z and 2z is 10z. And that's actually the answer. When we simplify an algebraic expression, the answer will contain variables. This shows that no matter what the variables stand for, we'd have a range of answers. It's not like solving an actual math problem like 2 plus 2 is 4. It's simplifying an expression. It's condensing it, okay? Take a look at this one. Bob earns $12 per hour. He worked X hours the first week and half that number of hours the second week. Write an expression for the total amount of Bob's earnings for the 2-week period. All right. Well, we know he makes $12 in 1 hour. And if he worked X hours 1 week and he worked half of X the next week, then that means he did X plus half x at $12 each hour. See? So this is 1 week, and that's the second week. So we need an expression for the total amount. That means we're going to be adding. So now we need to multiply by the amount of hours he worked. This is the first week, x, and the second week, half x. So we end up with $12 times x plus half x. See? You get that? All right, try this one. Emma's grade on her first test was X. That's important. She scored 9 more, that's important, points on her second test. That's important. She scored 9 more points on her second test than her first test. Write an expression that shows Emma's average on the 2 tests. And we're going to have to figure out an average for 2 tests. So we think her first test grade was X. Her second test grade was 9 more than X, so it's X plus 9. But it wants an average, and an average is found by adding the 2 test scores together and then dividing it by the number of tests that we added, 2. So here's the first test, x. Here's x plus 9, the second test, and we write it as a fraction like this because that means division over 2. See? Does that make sense? Okay, you're on your way to becoming a professional algebraic word problem person, okay? I hope this is helping you, and I'll see you next video. Bye.